Imagine this, an entire country's air travel system. Every single plane just stops, all at once. They're ordered to stay on the ground. Now, that sounds like the plot of a disaster movie, right? But this isn't fiction. This is the story of how a single critical database failure did exactly that. The day was January 11th, 2023. And that's a date that's now etched into aviation history as one of the most massive and honestly, one of the most revealing disruptions we've seen in a long, long time. So what on earth could possibly halt over 11,000 flights in just a few hours? I mean, your first thought is probably weather, right? Or maybe a major security threat? Nope. The culprit was something much quieter, something buried deep inside the digital plumbing that's supposed to keep our skies safe. So let's get into it. How a single corrupted file brought the most sophisticated aviation network in the world to a grinding halt. The whole story revolves around a system most of us have never even heard of, the FAA's NOTAM system. And you have to understand the scale of this. It was absolute. We're talking every single commercial flight, every private plane, every cargo jet, everything. It was a complete and total aviation standstill, the first one of that magnitude since 9/11. So the big question is, how could this possibly happen? Well, the answer lies in a classic case of a single point of failure. It was really a perfect storm of a vulnerable piece of tech and, you guessed it, simple human error. The heart of this entire mess is the NOTAM system. Think of it as the digital bulletin board for every pilot in the sky. It delivers absolutely critical, real-time alerts about anything that could be a hazard. Things like closed runways, equipment outages, or flight restrictions. Without it, flying safely is basically impossible. And this just shows you how fragile that whole system was. The sequence of events is almost terrifyingly simple. It started with what was supposed to be routine maintenance. Then, a contractor accidentally deleted some of the system's core files. And poof, the whole thing just collapsed. There was no live backup to seamlessly switch to. The system was so old that its only backup had to be manually reloaded, a process that takes hours, not seconds. But here's the thing. This wasn't just about one person's mistake. That was just the spark. The system itself was a ticking time bomb. It had no redundancy, so no mirror system that could take over instantly. No automatic failover, not even a simple undo button to roll back the bad change. It was all running on ancient infrastructure with really poor controls. So when you boil it all down, this wasn't really a technical glitch in the traditional sense. It was a massive failure of what we call database governance. That just means the basic rules, the safeguards, the design principles for how you protect and manage a system this critical, they just weren't there. Now, the failure of this one database didn't just stay in a server room at the FAA. The consequences rippled out across the entire country. So let's actually look at the immense cascading cost of this one event. The main number is just staggering. Over 11,000 flights were either delayed or outright canceled. That stranded hundreds of thousands of people and just threw the entire country's logistics into chaos for days. And the fallout went way beyond the airport terminals. This single outage triggered urgent congressional hearings to figure out what went wrong. It kicked off these big national cybersecurity reviews for all kinds of critical infrastructure. And maybe the one silver lining is that it forced the FAA to finally hit the accelerator on its modernization plans, which were long, long overdue. Now, while this whole thing felt completely unprecedented in the moment, if you zoom out and look at the broader history of critical databases, this story is actually, well, it's pretty familiar. This FAA mess is just another powerful chapter in a long book of warnings we've seen before. When you put the FAA outage next to other major database disasters, a really clear pattern starts to emerge. Back in 2012, a botched software update at the Royal Bank of Scotland locked millions of people out of their bank accounts. The lesson? Those old legacy batch job systems are just too risky. Then, in 2018, TSB Bank's disastrous data migration locked out nearly 2 million customers. The lesson there? If you're going to modernize, you better have a bulletproof backup plan running in parallel. And the FAA in 2023? That was the ultimate lesson. For our most critical national infrastructure, there is no such thing as acceptable downtime. So what are the big takeaways here? Or maybe the question is, what are the lessons we seem to have to learn over and over again? First, legacy systems can't just be patched up forever. They have to be properly modernized with things like redundancy and instant rollbacks. Second, our systems have to be designed to expect human error and contain it, not amplify it. And finally, we have to recognize that for systems like this one, keeping the data available isn't just an IT goal, it's a fundamental pillar of public safety and national security. The entire U.S. aviation network was brought to its knees because at the end of the day, it all depended on one aging, vulnerable database. It really makes you think, doesn't it? What unnoticed system, what single point of failure is your world, your finances, your healthcare, your day-to-day life silently depending on right now?